Welcome to this episode of Crops TV. Today we have Dr. Mahari Tahasta, and he is going to talk about soil compaction management. And as we go through the presentation today, I'll probably interject a few questions related to his presentation. With that, Mahari, I think we're ready to roll, so I'll turn it over to you.
Thank you, Aaron, for inviting me to give this discussion and talk. At this time, I also would like to give appreciation to the co-authors, collaborators for this research at Iowa State University. I'll go through first the introduction and what is that vehicle-induced soil compaction from a measurement approach. And then on the application side, what are the effects or the impacts of soil compaction from a field machinery on soil and crop yield? There was this farmer's perspective, a survey done in 2013. There were a few questions that I had picked out of the total that are relevant to soil compaction topics. What I would like you to look at is the percentage, what farmers' perspective in terms of their relevance to the particular questions. So if we look at the top three, they are related to soil moisture content. If it is important, what it says is I consider the soil moisture content in fields as I plan field work in order to avoid soil compaction. Survey shows that there were about 59%, above that 50% where they say, yes, we do consider soil moisture content. What that means is when the soil is wet, it's susceptible to creating soil compaction. On the top, you would see it as a rut formed behind the wheel. And then, deep soil compaction also gets deeper when the soil is wet. The second one is I'm concerned about the impact of heavy machinery traffic on soil health. So that's also this is from 2013, as high as the top three, if you look at them, they're about, 60%, close to, on average, the same, about 50, 58, 59. The third one, if you look at it, a wheel traffic pattern control is an effective way to reduce soil compaction. So what's so common among those three, if you look at them, is a machine weight, which is why they have a heavy machinery. The condition of the soil, the wetter the soil, the more prone it is for soil compaction. If you control traffic, possible reduce it or control it. That also helps in reducing the soil compaction. The other one that is also relevant to soil compaction is I consider the weight of an agricultural machinery as I make decisions on new equipment purchases. Now, if you look at that percent, that's lower than what you see on number two. And that's kind of interesting because ag machineries are getting bigger in size and heavier over time. Why farmers would buy bigger and now faster for a lot of either planting or tillage application or sprayers is to gain productivity. You could finish the field work at a shorter period of time per given operation. If weight of the ag machinery is considered less, but the weight, the axle that it introduces into the soil is compaction. So this kind of they seem to be like opposite to each other. You would have say the heavier the weight, the heavier the axle load, and the issue could be higher on soil health. What I'm saying here is, soil compaction is a concern. If you look at the farmer's perspective. Now, if you look at the same question about how important is soil compaction when you judge soil health? That was also another question that was asked in that 2013. 74% say very important. Similar survey that was done in 1993, they also had like 59%. Now, we are in 2023. If I would ask, would this be the same as what was in 2013, or would it increase? Most likely, if you look at the top especially the second one, and what we consider the weight of the ag machineries, they keep on increasing. So you farmers probably would have rated it higher when you judge soil health. Two things. Machines are part of the ecosystem in a crop production system. So farmers are concerned about soil compaction, as soil compaction is related to the soil health. And looking at the historical perspective, how does a machine weight related to farm productivity? For increasing farm productivity, both in working in a timeliness manner to harvest crops as fast as you can from a field, or try to do a field work within a higher productivity rate or area coverage per day, you tend to look at more of a bigger and wider equipments.
On your previous slide, you talked a little bit about winter freezing and thawing. How effective can freezing be comparing dry conditions versus saturated soil conditions on breaking up compaction?
Yeah, I think that's a good question. So if you look at this, that was also one of the survey question. I believe that winter freeze and towing and summer shrink and swell are sufficient to address soil compaction on the land I farm. This is a farmer's perspective. Part of the reason maybe why it's low is, yes, freezing and towing would help if they come very frequently and if the freezing and towing goes deeper. If we look at the top soil compaction, freezing and towing would help if there's more frequent of that freezing and towing cycle. When it comes to the deeper soil profile, we had this kind of questions brought up in a different extension reports or other researchers in the Midwest. It depends on how deep the temperature change in the soil happens deep, and often it may not change that much, especially with the cycle of freezing and thaw. So the percentage is lower here when you look at what a farmer would think. Maybe because the geographic location of the farmers may vary, but it does help, alleviate some level of compaction, but it would depend on the frequency of cycle of freezing and towing and how deep does it go.
So just to summarize, the depth can vary based on soil moisture conditions and soil temperature,
Yes.
obviously, and more frequency of that freezing thawing action is more beneficial than a single freeze thaw cycle.
Correct. Where I'm trying to go and lead into the system is we're looking at a system level. You have a machine, there's a soil, and soil is an ecosystem, that supports machinery traffic for field operations, and it is also a medium for plant growth. And what a farmer would end try to get out of the field will be, a maximum yield for a good return on investment. Now, in this system, one of the easy to measure is the weight of equipment. So over the years, we have seen this continuous increase in weight of machines. So what you see on the left, it was from a news letter by Frank Bankenham, and there was a title "Grain Harvesting into the '90s." So if we read that, the limits to combine size have just been reached. So how will farmers get more capacity from future designs? So according to this newsletter, what you see is a big problem is compaction from combines and grain cups. Back in the 90s, there was a concern about compaction and how combine engineers would consider that. And one of it is because of the weight that combines and grain carts would have. Back to the 2023, what you see a table on the right, this is what we measured at Iowa State. What I would like to highlight for you is, if you look at combine, a grain harvesting platform with a header, 12 rows on a 30-inch row spacing, full tank, you're looking at 31 tons per axle on the front axle of it. So I was looking at a publication from Iowa State Extension in 2000. The estimate on a front axle, I wasn't sure if it was grain cart or a header, but it was 17 tons per axle. So looking at that, we're looking at double the front axle load of combine. If we look at the 22 tons per axle, that one is just without the header, but full tank on a combine that weighs about 22 tons. That's still also higher, even if the data from the 2000 Iowa State Extension 17 was, without the header. What that means is, combines, they have more weight in the field than what they are on a highway. On a highway, you don't have a header, the tank is not full. So that's what we're looking at. The weight per axle is almost double if we compare over 20 years. Another important point that I would like to see, if you look at a lot of these field machines, the tonnage per axle for either a mechanical front wheel drive track tractor or wheel tractor, and also sprayers, all of them have greater than 10 tons per axle. There was a study in the 80s, many studies in the Midwest, Europe, where they did try to quantify, what is the axle load per that could create a potential excessive soil compaction. They came up with 10 ton, metric ton per axle would be kind of a limit if we want to avoid a deep compaction, especially below 20 inches. So most of our machines that we see in the field right now, they have a weight way they exceed what the soil could support. Weight alone is not the cause of soil compaction, as you look at even from a farmer's perspective earlier, the wetter the soil, more traffic. There's a lot of factors involved into the compaction in creating it. But one of them is we see this continuous increase in axle loads, what we see machines in the field. We look at machine is part of an ecosystem in a crop production. And we also realize that compaction is a problem as one of the soil health indicators for either the environment, because increased soil compaction will reduce infiltration rate, it will decrease yield, you would need tillage, which is an expensive operation to break compaction. Now, what are the approach to either measure them or use computer modeling or use field data to quantify soil compaction? One approach that we have done is using computer modeling to compare axle load from a cotton harvester. We were interested in looking at IF, which is increased flexion tires, VF, very flexion tires, versus a standard radial tires. What's the difference in compaction that a cotton picker would have? We were able to show that the increased axle load and the high tire inflation pressure caused a significant increase in predicted soil stress, peak soil stress, which is related to soil compaction. The heavier the load with the soil properties that we use it for the soil modeling work, it was collected in Australia on vertisols. They're very swelling and cracking soils, and they tend to compact a lot. The heavier the load, the high tire inflation pressure, it also created a deeper compaction where it would need deep tillage operations. Another approach you could measure or quantify the effects of soil compaction would be through a field experiment. I'll go in detail about this. This is from a study at Iowa State that we did for about 3 years. We had compared tractor and planter configurations for new tire technologies, IFVF, and we saw about 4% gain in yield compared with the standard radial tires. Another approach is, looking at the plant response. What does the plant look like, or the root system? You could also quantify the effects of soil compaction. In particular, when you think about a pinch row compaction, a pinch row is a row that's halfway between, like if you have a dual tractor tires operating in the field. How is that pinch row on a 30-inch row spacing compared to the untrafficked? What you see here is, we saw a lot of variability in the ear diameter and lengths compared to untrafficked. So one of the advantage of measuring compaction like row by row would be to reduce plant-to-plant variability, which is very, very important. If you reduce plant-to-plant variability, especially during emergence stage, that really helps in managing soil compaction. One of the technologies that would help would be to reduce tire inflation pressure or to minimize unnecessary traffic in the field. On the bottom, roots, when they're growing without restricting soil compaction, they tend to have like about 30-degree angle moving down with a much denser root mass per area. But if you look at compacted, this is about V4 stage of the corn plant. What we found was that the roots were kind of going horizontally. We didn't see a lot of root mass from the plant that was on the pinch row compaction. What you see on the right are like 4 plants. They were delayed by about one vegetative stage on an excessively compacted pinch row location. What you see on the right is the end traffic. So if you could minimize this plant-to-plant variability due to either doing a very good measurement or applying the right tire inflation pressure, you could take advantage of an existing system on the tractor or a planter for that matter, or reduce traffic control. Sometimes it's very difficult to choose, soil wetness, when to go, when not to go, especially during planting operation, because one of the need for planting is to get a good seed to soil contact. So, and then the timeliness to start planting. The earlier you go and plant, it's the better. That's what agronomists would say. But at least leveraging, measuring the axle load, using the right tire inflation pressure or the right technologies would help to reduce the plant-to-plant variability due to compaction. I'll give a little summary about compaction because, yes, soil does compact. It also rebounds. If you do not exceed the bearing capacity of the soil, or the pre-compression stress is what we call it, it could rebound. But if you exceed the load on the soil, exceeding its pre-compression stress or what the maximum bearing capacity it could do for elastic region, it will get compacted. Now, since compaction is an event that is likely happening due to soil moisture condition or heavier axle load or high tire inflation pressure, so if you look at it, it becomes more of a probability of events. So if we look at what are the high probability of events that would cause soil compaction, we look at operating on a high soil water content. If you look at relative scale, what that means is if you are looking at a plastic state of soil, which, if you roll it to like 1/8 of an inch, if it starts to crack, the moisture content of that soil is called a lower plastic limit. It's good to avoid working on a soil at that state of soil. The drier the soil is better for avoiding soil compaction. Another top one is, operating at high tire inflation pressure systems. When there is a high tire soil pressure systems at the ground, you are increasing the likelihood of creating soil compaction. So when we look at management of soil compaction, then how do we look at it? You could look at it more from managing what you have in terms of tire inflation pressure management or field trafficking, or you could also minimize operating in the field when the soil is not ready for supporting excessive loads. So you look at it management from that perspective, either from the machine parameters or field operation from controlled traffic, or mapping it if possible, and also the soil condition.
Yeah, just to kind of reiterate, when we talk about high PSI in particular, I think some of these newer tires that we have, I mean, I think our study looked at like upper 20s. I mean, is there a happy medium? I mean, obviously, we're going to look at some low soil or so low tire pressures that are going to have the ability to reinflate those tires on the road. So, is there somewhere between 6 or 8 to 29 psi we can run with tires?
Wow, that's a very good question. So if
There's
I
yeah, there's a lot to unpack there.
Sure. No, that's really good, good question, Aaron. Yeah, I think what you're looking at is, say, if you want to go from like a road speed, or sometimes the road load is way higher than, the field load. For example, planter, if you look at 24 row planter frames, they are folded on the road. So the center tires support a lot of load. So you need to inflate them for like a field load, and then the field speed often in the 30 miles per hour. But if you're working in the field, sometimes the load for a planter, when it is unfolded, the load will spread. The speed you're planting way lower than what you have in the road. So if you're just looking at the tire speed and load, recommended tire inflation pressure, you look at it from 6 psi, 9 psi when you're operating in the field to all the way 29 psi. So that's very interesting because that tire that a farmer has on that machine, if it has the latest technology of tire, either IF or VF, it is designed to operate under that wide range of tire inflation pressures, from all the way to the lowest that you could do to the highest. The question that you're asking is there a medium, happy medium range where you don't have to, change the tire inflation pressure? I think one thing that I could interject into this discussion is, if you have a tractor with the planters or any implements on the back, you have to inflate them to be for the road condition. So if you are in the field, to deflate them and then inflate them back to the road condition before you go to the road, you would need some kind of compressor system, attach it, or work out from a custom build systems to change those tire inflation pressures. So most equipments, they don't come with that. You cannot be on the road at 6 psi or 9 psi. The tires don't have a durability to support a high speed and heat on the road. Now, if I understand you again, your question, which I think it was relevant, is there like a range where you don't have to build a custom made, or there's a lot of technologies, what they call central tire inflation pressure systems, where a farmer could change the tire inflation pressure from a cabin? What would be that the lowest you could go, or partly the highest you could go, you could still be working in the field and the road? The answer for that is, I don't have that answer. Okay. I think that's a good question for a tire engineers or dealership when farmers work with their equipments. Why I'm emphasizing that part is, tires are structural systems. They have a fiber, they have reinforcement systems. So the tire manufacturers design them, test them to be what they are. I'm not aware of what a tire manufacturer would recommend to be, both for field and road right now. There might be, but at least I'm not aware of for tractor or planter implements. At least that's what we were doing a lot of the research. We're now doing with a sprayer system too. That's a good question, but the reason why I'm emphasizing that I don't have an answer for that is because, to use this opportunity, that's the thing that we need to study more. For example, if you go to like 26 psi or 29 psi, which is way high, the soil cannot support that compaction. But if you go as lower as you can, still the effect of soil compaction that is created from this new happy medium, I'm not talking about medium between low and high, but somewhere in that range where that tire could be on the road for the road speed, road load, and the soil compaction will be way better or less than the maximum soil compaction that you could have, which is tremendous gain, in my opinion, because what one of the thing is, if you keep your compaction within the top 6 to 8 inches or even 12 inches, farmers can apply some kind of tillage system, either disc in fall, or even disc cultivator harrows during spring that could break that. So tire inflation management system is very, very important. Anytime that you lower your tire inflation pressure, you're also making your compaction shallower. So we know that at the very low tire inflation pressure, which is the lowest you could have for the lowest speed of that field operation, you would see that we saw a big yield. But I think there might be somewhat a medium from a soil compaction perspective or yield that we don't know yet, but we would need to study that.
Thank you. Yeah, just to kind of summarize, so as we get into varying moisture conditions on our soils in Iowa, that we want to be sensitive to that as we make adjustments in our soil or in terms of our pressure on our tires. And especially if we, are roading these pieces of equipment long distances, we may consider airing them up more of a road speed and adjusting that as we, are on the road and go further and further. There's not uncommon to go 10, 15, 20, 30 miles sometimes on the road.
But I think we have, but farmers have something that they always need to do. One is weigh their machines and put the right or tire recommended tire inflation pressure. Sometimes we have seen that the tires are way higher than what you could lower, even for the load and the speed. And sometimes, you would find machines in field operation, where farmers would have benefited if they know the actual load. Sometimes measurement of what you could do would be the first one, like a combine. I don't think you could easily find, what exactly is the front axle load, because when a combine is full tank with a header on the front of it, it could carry about 70% of the whole weight. But if you don't have the heading on it, you're looking at 50 to about 50% weight on the front axle. So measurement of weight, measurement of tire inflation pressure, and also put the right tire inflation pressure according to the tire manufacturer. This could be easy hanging fruits to manage soil compaction.
Yeah, great tips, Marty. I think that's something as people want to fine tune their agronomic systems to, kind of weigh those machines. And if they have the ability to weigh the combine with the header on, we can calculate the grain in the tank. Just a great preseason check, especially on planters, to go through those tires on the planter as well as that tractor planter that we're using or using to pull it and see where we're at. So thank you. Moving on.
Now, there's all this discussion about soil compaction is effect on the environment, effect on crop yield. What are those management things that you could do on machines? What I would like to kind of bring step by step now is, if we want to measure, which we need to, sometimes soil compaction is not measured. Okay, it's just implied. Maybe there's no good measurement method because of a soil variability, or sometimes there are no equipments that you could, often use in the field to measure it. So I'm going to go through the system process of it. One way to quantify is to really measure that footprint of soil, and then you could look at a soil stress, at shallow and deep. So at Iowa State, at the Soil Machine Dynamics Laboratory, it's in Boone, Iowa, at the Agricultural Engineering and Agronomy Farm, we have an indoor facility where we can measure the actual footprint of load applied from tires or track, row crop tractors, sprayer. We've been doing this now regularly over the last 1.5 years. What we do is we measure the footprint on an artificial soil. It mimics very closely in terms of its mechanical behavior to natural field soils. I had asked my graduate students last year to quantify, how far are we our artificial soil from soil compaction. They sampled 5 soils from Milwaukee, Minnesota, Kansas, 2 from Iowa. We were kind of within 7% off from the natural soils. So the reason is when you're indoor, you control the soil. You have very consistent soil behavior as compared to a field soil where you could change it either by soil type or moisture, and you're not get a very accurate measurement of footprint. That's why I'm showing that on the top right. We did measurement in the field. It depends on if the soil is wet or dry. So we this is the first thing, and what I start saying now is compaction starts at the footprint. So if there is a data that farmers or engineers or extension people have, what exactly is that footprint that a tire creates or track would create, and you could calculate the ground pressure, which is the load divided by that area. So the bigger the contact area, quantified, measured, will tell you, what is that reduction you could do on soil compaction. So you could do this before you even go to the field where you're measuring the true footprint measurement on tired soil. There are measurements that tire companies publish on a hard surface, which is just a concrete type. We found out that that's not a representative for farm machineries because it does not reproduce the actual soil deformation and tire deformation. So if we look at tires and soils, there are two systems. The tire is like a deformable material, even though it has more stiffness than the soil, and the soil is also a deformable material. So you get that true representation if you measure it on soil. If you measure it on hard surface, it does not tell you the accurate measurements. I gave a presentation in Houston, Texas, a year and a half, 2 years ago. What we found was, relating to those tire inflation pressures, row crop tractor, bows, and track tractor, they were ballasted properly for 24-row planter application. We measured indoor, what's the footprint track versus the wheel. According to the tire manufacturer, you could operate the rear axle on it's 48 80 R50 tires at 9 psi for planting operation. You could also you need to operate them close to 26 psi if you're on the road on a folded planter system. So if you have a way to change this 9 to 26 psi, we want to know what is the gain? What's the difference in footprint compared to a track? The track is 24 inches, track width about 80 inches long on the rear axle. What we found was the duals from the wheeled track tractor, it's a mechanical front wheel drive, at 9 psi, it had about 5%, a higher footprint area compared to the track. But when you do the footprint measurement at the 26 psi, the track had significantly higher footprint than the 26 psi duals on the back. So it's very important because when you measure it, you have a number that you could quantify. If you were to do it on a hard surface, you're not going to get this representative behavior. And then the other thing that what you can measure in our lab system like this, not only the area, an area is just a projected area where you have the maximum lengths and the widths. We also measure the number of lugs. How many full lugs are penetrated from the tractive system. So we found about a 1 lug extra if you measure it on soil compared to a hard surface. Was tires. Was track, we didn't see any difference, the number of lugs. Another thing that we measure is, what's the penetrated volume, which is kind of similar to a rut depth, even though our testing is vertical load. our measurement in the lab compared to what we measured in the field under field-tilled, relatively moist soil, not very wet or not extremely dry, we were close to less than 1/16th of an inch difference. So you could measure the volume of the penetrated soil, the number of legs, and then the area accurately. So if you know your tire inflation pressure and you know your load, you also know what will be the benefit of either increase it or decrease the tire inflation pressure or track versus wheel in the lab before you go to the field. You have a very good soil management plan. We also start measuring soil stress, which is, when you bury a sensor inside the soil, what will be the effect of changing tire inflation pressure, in this case, road setting and then CTIS setting. The wheel tractor was a single wheel, both on front and rear, and compared to track. This was sponsored from a small grant that we received from Sears at the state of Iowa, through the Iowa State University, and then a small company here in Ames. They have a central tire inflation pressure system. It's called AgriBrink. They came from Canada. So with that small grant, we were able to kind of do a demonstration, how could you measure that shallow and deep compaction just to compare tracks or wheel systems? And I'll go through that quickly, okay? This is more from a demonstration or extension type to quantify the effects of wheel versus track. We measured at 8 inches, 12 inches, and 20 inches using our sensor. We have a sensor at the Soil Machine Dynamics Laboratory. We buried the sensor and we measured peak vertical stress. So anytime that you measure that peak stress, that's related to soil compaction. So I'll go through that quickly. It would be more to illustrate some of our findings. It would be more from, you could do early comparisons like that. It does not mean this is what you will get in the field when you're doing crop system, because this is more on a remolded soils. I'll go through that quickly. So we compared high tire inflation pressure, low tire inflation pressure, but both the high and low are the tire manufacturer recommended tire inflation pressures. So if a farmer would have a central tire inflation pressure system for this 9R, with the VF 650 60 R34 on the front, and then VF 960 R42 on the rear, with a measured weight of close to 6K, and then on the back is close to 8. What will be the tire inflation pressure? We look at the table from a tire manufacturer. If you are on the road speed, you would need to inflate them to 29 psi. And what's the compaction that we measure? If you look at the 8, 12, and 20, the peak compaction we measured was at the 8 inches. And then as you go deeper, usually the compaction stress gets smaller and smaller. But if I will show you what does that look like for a central tire inflation pressure or low tire inflation pressure system. Pay attention here, this is from the front axle wheel. We're looking at 30 psi, and then about 40 psi or 38 psi on the rear axle at 8 inches. And at the 12 inches, you have about 20 psi. At the 20 inches, which is deeper, you're looking at about 10 psi. Even by just one tire configuration platform, we could look at how deep are we creating the compaction. So 15 psi is a good threshold that if you keep your soil stress within 15 psi, soil tends to recover better. Because soil rebounds. It does not rebound a lot. It's not like a rubber. It does deform. It has because the excessive load in psi is what the soil can support. You could still control it. Another thing is, if you have that 15 psi, if you look at this system, it is within what you could do with deep tillage. Deep tillage is often, down at 12 inches, or sometimes 10. You don't go that deeper than that for either power or the design of the shanks. Now, if we look at, the other one, it's a low tire inflation pressure, same tractor, the same load, same tire. But if you go into a tire manufacturer table, if you're trying to do a low speed, this is for field type of speed applications, mimicking a planting operation at 5 to 6 psi, 6 miles per hour. You could deflate the tire from about 29 psi on both ends, from 29 to 8 on the front and 6 on the back, if you have a system. With the AgriBrink, they did a demonstration when we were presenting this last summer at a workshop. They have a very quick system where you could inflate, deflate. I think it was close to like a minute. So from a soil compaction perspective, if you look at the high tire inflation pressure, if you look, it was about 30 psi. With this low tire inflation pressure, you're looking at close to that what the soil could support, about 15. So you reduced it by half. So just inflating or deflating the tire, you could really gain a lot in managing your soil compaction in the soil, inside the soil. So you would gain a footprint. We did not measure our footprint for this tire, for this tractor, but you could see that you gain a lot on the lengths. You don't gain that much on the width, but you gain on the lengths compared to the high tire inflation pressure. At 6 psi, you're looking at all the compaction are manageable. When you go deeper, it's still below what that high tire inflation pressure would do. So from this, it's more about a demonstration on a pit that we put our sensor, but it allows, engineers, growers, extension agents, and us researchers, if I have just changing the tire inflation pressure by how much I can reduce my compaction in soil. We also measure track. It weighs about 39,000 pounds. It had more weight on the front axle. It's a rubber track tractor. This one we're still learning about track systems. What is the soil stress, especially below ground? How deep, is the axle load causing most of the compaction, and how does the idler wheels, buggies would create compaction or not? This data is still not conclusive. Okay, we're doing a lot of further studies, because most of the time, if you want to do soil stress measurements with tracks, it would work better if you have an implement on the back to do a more representative weight distribution to get a good measurement. We learned one thing, I don't know why the rear axle of the rubber track tractor had lower soil stress measurements. We didn't have data on the front versus the rear axle. But when we look at the front axle load, we could compare this with the wheeled tractor, both at high and low. The rubber track tractor on the front axle had created always higher soil stress compared to the wheeled single tires on the front and rear, at both for the 29 psi and definitely way higher than the 6 psi. Another observation, what we found was that the front axle from the rubber track tractor and the buggies on this one, they were creating also compaction. So at the deep, like 20 inches, so remember, you cannot do deep tillage to remove deep compaction as deep as 20. So that's why it's very important to avoid deep, heavier axle load or operating on an extremely wet condition, because you could bury the compaction And the only tool to alleviate soil compaction in this kind of system, if it's very deep, will be that what Aaron, you had asked me, freezing and towing, because there's not a lot of tillage that would go that deep. Again, this is more about comparing configurations of track versus tire inflation pressure. What changes can you have? So when we think about measurements, you would need to measure the weight. You need to know what is the recommended tire inflation pressures of the tires for the application. And then can you measure footprint? Can you try to get a data like this? If we keep on getting this kind of data, we could publish it at our website at Iowa State to educate the community. There are differences on the magnitude of soil stress that could be created. It's very, very helpful, because we generated data. We brought the most modern systems in terms of tire inflation pressure changings, which is one of the latest technology that growers have. And there's not a lot of data to know exactly, is it worth it to buy a new tires, or is it worth it to have a CTIS systems? But when you have data, it adds your decision metrics. So the point is this: tire inflation pressure weight measurements are important. Lowering the tire inflation pressure would keep the soil compaction shallower. You could also reduce the magnitude of soil compaction that you would do in the soil, inside the soil. You would also gain the footprint. You get more foot lengths per tire. The only thing that you're changing is tire inflation pressure. With track versus wheeled system, I think what I would say is we still have to do a lot of research. We don't have a good. We need to do more research to understand, especially like there's a lot of 4-track or quad-track type systems in the farm. We're planning on doing this again in spring. We have a workshop that we're planning to do at Iowa State at the Soil Machine Dynamics Laboratory in collaboration with the Ag Engineering and Agronomy Farm in summer 2023. It's going to be soil compaction clinic. We will do similar measurements like this with different manufacturers. Stop it.
Just a couple of take-home message that you reiterated. I think real nice. I think producers need to understand a couple of numbers, and you did a great job explaining those numbers. And so hopefully everyone has a good understanding. But 15 psi is the maximum soil pressure that ideally we would like, and so growers are going to want to be conscious of that number. The other number is depth. I think that's something that we oftentimes maybe don't think about because we have pretty good size equipment, and where tillage is able to be done, we do that. But I think once we start exceeding that 12 to 14 inch range in terms of compaction depth, it's very difficult to mitigate that with man-made equipment in the Corn Belt, I guess. And so I think those are numbers that people need to think of. And the other thing is the 2-track picture that we're 2-track machine that we're looking at here. There's not really much adjustment to them other than if you decide to change your track width. And so I get this question a lot, and there's a lot of arguments in the country between track machines and wheeled machines. Just know that you have a lot of versatility with the wheeled machine in terms of if you have the ability to change the PSI of that particular tire. So I think that's kind of, in summary, I think those are some great take-home messages that people need to be aware of and understand that Dr. Mahari and his team are doing a lot on soil compaction. And if people have specific questions, to feel free to reach out. So.
An overview, the question always comes is, do you know what is the yield penalty if you don't do a good soil compaction? It varies from so many studies that we have done on both literature review and our study. It varies from 4% to 20%. 20% will be more excessive soil compaction, like we here at Iowa State. We've been doing a study on soils impacted by heavy machinery during construction of pipeline activities. That's where we saw those, especially on the first few years after compaction. What's the cost for compaction? On average, you're looking at about penalty of $40 per acre. Does soil compaction stay longer on the field, especially when it's below that 20 inches? Yes. If deeper compaction could last about 10 years. There was a lot of studies from Minnesota, Ohio, where they were monitoring compaction. In other words, it's very interesting, right? Compaction is a probability other, right? If you go under a weak soil condition and you apply load or trafficking that would cause excessive deep compaction, you're going to have that penalty, for a longer period of time. Another thing is when compaction is created, it needs to be removed or loosened. And if you put iron on the ground or pull with tillage operation system, they take time and cost.
That's a great final slide there. I think the long-term effect of deep tillage in a really wet year can really impact our systems, especially in corn-on-corn systems, just because of the amount of wheel traffic that we do and the amount of bushels that we haul off. So
I think one of the question that always comes is, does it pay off? How much yield advantage would you gain if you try to implement or introduce technologies? Or, how much is the severity of soil compaction on yield? Those questions, I would try to highlight them on two things. One is, our study had shown that 4%, that's a lot of differences, okay, if you could gain this. Another thing that we have found was that if you create a lot of plant-to-plant variability, Purdue University has done a lot of study. Anytime that you lose that plant-to-plant variability, especially the plants that does not emerge, about the same height or the same V stage, especially on the younger plants, about V4, they will delay. We're learning a lot. You're just increasing the crop to crop variability, especially on that traffic path. And even though the percentage on the bulk, so if you're combining it with, 8 row or 12, you may not see it on that combine. There's a lot of opportunities to reduce the impact of soil compaction if you understand that plant to plant variability. Planter technologies are like that. Any planter that you see in the market was studied. It shows that plant to plant variability, tillage systems the same, speed the same. So we're trying to add that knowledge with compaction. You need to pay attention to that plant to plant variability, what compaction would do, especially in that tillage, planting, and spraying. All
yeah, I
right.
think that's agronomically, we look at that a lot as agronomists within Iowa State. I think the harvest process today causes us maybe a little more compaction than we want to admit. As we take these 12 and 16 row cornhead combines and we put bigger grain tanks on them and we fill those and we chase these combines all day long on every square inch of that field with a 1200, 1500, 1800 bushel grain cart with a 400 horse machine. We've got a lot of compaction almost uniformly across the field. And so wet is a challenge in the fall that causes us, agronomic issues in the spring. But I appreciate all the information you shared with us today, Dr. Mahari, and thank you.